Hello, in our last two lessons, we have done the increasing, decreasing of functions and the local maximum, minimum. And today's lesson, we are going to do something regarding the rational function. Rational function is not a polynomial function. So rational functions means the two functions divide. And when we divided two functions, and the simplest function in the division will be the reciprocal function f at x equals 1 over x. When we do the graphing of this one, we know we have two branches. So this one and this. And the most important features for this one is it has two asymptote. One is a vertical asymptote, x equals 0. Another one is horizontal asymptote, y equals 0. So in this lesson, we are going to discuss more about vertical and horizontal asymptotes to rational function to help us to do the curve sketching. So when we do the asymptotes, we want to introduce one symbol, infinite. This is not a number, but we use it for the notation of infinity in limit. When x approaches c, then x minus c approaches 0. 1 divided by 0 is around infinite. If approaches from the right side, then it will be positive, so we say it is positive infinite. If from left side to approach c value, x minus c give you a negative number approaching 0, so 1 divided by negative 0 give you negative infinity. And when x approaches positive infinity, 1 over positive infinity give you 0. We don't discuss about positive 0. We could say it is positive 0. It approaches 0 from above. Approaches 0 from above. And this one, x approaches negative infinity. 1 over x is approaching the 0 from negative side. So this is from positive side, above the zeros. Another one is below the zeros. So we are going to discuss about the vertical asymptote first. So vertical asymptotes of rational function. So vertical asymptotes of rational function, it means the denominator equals 0. So what we are going to like our domain, the restrictions for the domain. So a rational function of the form f at x equals p at x over q at x. Both p and x, q and x, they are polynomials. Polynomial functions. Has a vertical asymptote x equals c, the vertical line. For all the vertical line is x equals a number, the equation for vertical line. And the c value is from the denominator q function when x equals c equals 0. So these are the zeros for denominator. So what we are going to find is just find the zeros for denominator. Then they are the vertical asymptotes. And here p, when c substitute to p, function p is not 0. The reason for that is if both q at c equals 0, p at c equals 0, then we can cancel that 0 out. We call that as a whole. So if q, c equals p at c equals 0, then x equals c is a whole. At x equals c, you will find a whole, so it's not a vertical asymptote. So in limit notation, a rational function f at x has a vertical asymptote that is vertical line, x equals a constant. If x approaches c from right side is infinite or from left side is infinite. So it means on the graph, if we have x equals c here, then from the right side either positive infinity or negative infinity. And on the left side, same thing, positive infinity or left infinity. So the asymptote, it means the graph will get closer to that vertical line but never ever cross it. So this is a vertical asymptotes definition. And in this lesson, we are going to look for the vertical asymptotes for rational functions, and also we are going to look for the horizontal asymptotes. So how to find the horizontal asymptotes? We are going to use a limit. Find the limit of the function when x approaches infinite. So vertical asymptote is x approaches a number, a constant. And for horizontal asymptote is x approaches positive or negative infinite. So this is kind of like AND behavior, okay? So now we are going to see one example and see how we can find the vertical asymptotes. So example 1. We have a function. This is a quotient function, x divided by x squared minus 2x minus 3. And we want to find any vertical asymptotes. And we know that vertical asymptotes means denominator equals 0. So we are going to determine zeros for denominator. So once we have the zeros, then x equals 0 is our vertical asymptotes. So x squared minus 2x minus 3, this is a quadratic trinomials. We want to factor it. If it's factorable, that is a easier way to find the zeros. So this is simple trinomial, one act front. So we have no other choice. X times x give you x squared, no number at front. Then we want to find the two numbers times together give you negative 3. So times together negative 3, add together is negative 2. So the factors of negative 3 is a prime number, so we only have 1 times 3. And the larger number of the factor need to be same sign as a sum, so it will be negative. So this is a same sign as your sum, the larger number. Times together is negative, so one negative, another one need to be positive. So the first sign is from the sum, the second sign is from the product. It's minus, then you have different signs. So we have plus 1, minus 3, add together give you negative 2, times together negative 3. So 1x minus 3x give you negative 2x. So the factoring works. Then after that, two factors times together equals 0, then each of them may be 0. So x plus 3 equals 0, or x minus 3 is equal 0. Solve it, move the positive 1 to other side, we have negative 1. Then move the negative 3 to other side, we have opposite operation plus 3. So we have two zeros. And these two zeros we want to check. The numerator, this subbing is 0 or not. So numerator, we want to solve for zeros. Zeros for numerator, we let numerator equals 0 is x equals 3. So it's not equal to the two zeros from denominator. Now we know the vertical asymptotes. X equals negative 1 and x equals 3. So they are our two vertical asymptotes. And after that, it asks you to describe the AND behavior of the graph of the function for values of x near the asymptotes. So this behavior, it means when x approaches -1 from left side, approaches -1 from right side, what is positive infinity or negative infinity. So we are going to see. And again, we want to draw a chart to help us to find the positive or negative. So this is x-axis, and we are going to use all the zeros from the denominator and also numerator. The reason why we need to use all the zeros then, because around those zeros, the left side, right side, they may change the sign. So we need to include all the zeros. We have 3 zeros, and we divided the x-axis into 4 intervals. So -1, then x equals 0, then this is x equals 3. So here is our function f at x. So we want to find f at x is positive or negative. And in order to find the f at x is positive or negative, we want to see all the factors. So we have the numerator is x, denominator we have x plus 1, x minus 3 as factors. Then once we have the negative, positive, we are going to find f at x is negative or positive. Then we are able to know that around the vertical asymptotes or around the zeros where the function is positive or negative. So this is f at x. So when x is -1 on the left side is x less than -1, we pick a random number. We can just pick the -2. We sub in x equals -2 is negative. -2 plus 1 is -1 is negative. -2 minus 3 is negative. So these 3 numbers, this divide by that is, if it's all number of negative sign, it gives you negative. Then we know that this is asymptote, so it will be infinite. So here it will be around negative infinite to approach the x equals -1 vertical asymptotes. Then from the -1 to 0, we pick a number -0.5. So sub in x is -0.5 is negative, -0.5 plus 1 is positive, -0.5 minus 3 is negative. So negative, you have 2 negative number, then multiply or divide give you positive. It means if this is asymptote, then it will approaches positive infinite near the asymptote. And here x equals 0, so this is not asymptote. So this one is from 0 to 3. We pick a number, could be just x equals 1. Sub in, so this one is a positive 1. This is 1 plus 1 positive. 1 minus 3 is negative. You have 1 negative sign, multiply, divide, you have negative. So this x equals 3 is asymptote, so it means it approaches negative infinity from this side is negative. And x equals 3, we could just pick a number that is greater than 3. We can pick x equals 4. Then sub in. So positive, 4 plus 1 is positive. 4 minus 3 is positive. So multiply, divide, all positive number give you positive. It means near the asymptote is positive infinity here. So Now we're going to write the conclusion. Therefore, the limit when x approaches 1 from left side is f at x equals negative infinity, because on this side is negative, and around the asymptote, vertical asymptote is infinite because it's divided by 0. Then from the right side, we have positive infinity. And the same thing for limit. When x approaches 3 from left side is negative, so it's negative infinity. And from the right side, f at x is positive, so it approaches positive infinity. And on the graph, it's kind of like this. So this is x, this is a y. Then we have the asymptote x equals -1 here. The graph is going this way, but never ever cross it, okay? And x equals 3 is asymptote. And on the left side is negative infinity, this side is positive infinity. And between this is 0, if we connect them, it will be something like this. So this is a sketch. So we couldn't find the local maximum, minimum. We didn't find it. We just want to focus on the behavior near the asymptotes. So this is going down, going up, going down, going up around the asymptotes. This is a numerator equals 0. This is our 0. So the sketch of this one, just use zeros and asymptotes, is like this. So in this example, what we have done is we find the zeros for the numerator and the denominator. Then we use the numerator, denominator zeros to create the chart. 3 zeros, we have 4, 1, 2, 3, 4, 4 intervals. Then we pick the number in that interval to check each factor is positive or negative. If you have odd numbers of negative, you have negative. If you have even numbers of negative, then it's positive because they are multiplying or dividing. And based on the negative or positive, we know it's approaching negative infinity or positive infinity. So this is for example 1. Then we are going to continue to see the example 2 to practice more. So example 2, we are going to focus on the horizontal asymptotes. And in order to find the horizontal asymptotes, we are going to use x approaches infinite, negative infinite or positive infinity. So, and we want to find the limit. In order to find the limit, same as before, we want to factor the numerator and the denominator and factor the highest degree out. We hope to cancel some of the x values, and we use the property 1 over x. When x approaches infinity is 0. Uses 2 limit to find the other limits for horizontal asymptotes when x approaches negative infinity or positive infinity. So for example, this one, this is a limit x approaches negative infinity. We want to factor the highest degree. This is 1, so we factor x out, then x divided by x is 1, then minus 2 divided by x. Then the limit multiplication, we can separate it. So limit x approaches negative infinity, we could separate it This is 1 over x. Then times. This is 1 times 1, so 1 over 1 minus 2 over x. Then limit 1 over x give us 0. Then times. Limit x sub in negative infinity, we have 1 over 1 minus 2 over x. When x approaches negative infinity, give us 0. So the final answer is 0. So it means this limit value when x approaches negative infinity give us 0. So this is not finding the horizontal asymptotes or vertical asymptotes yet. We just want to practice with how to find the limit, the value of limits for the expression. So this one, x approaches negative infinity, we are going to do the factor the highest degree out from each numerator and the denominator. So highest degree for the numerator is x squared. We factor x squared out, then divided x squared to each term. So 2 over x divided by x squared is 2 over x, then minus 1 over x squared. The reason why we want to do this because we want to have 1 over x. 1 over x, when x approaches infinity, give us 0. So that's the reason we want to factor the x highest degree out. Do the division 3 minus 2 over x plus 6 over x squared. Then x squared, this common factor cancel out. So we are going to sub in x negative infinity to this expression. So numerator is 1 minus 2 over x. X approaches negative infinity, give us 0. And 1 over x squared, we could think is 1 over x times 1 over x. Limit of that one is 0 times 0, or 0 squared. So the denominator will be 3 minus, we could write 2 times 0, okay? 2 times 1 over x is 0, then minus 6 times 1 over x squared is 0 times 0 is 0 squared. So 2 times 0 is 0, 0 times 0 is 0, so numerator is 1, denominator is 3. So this is how we find the limits for this one by factoring the highest degree out. Then we cancel x squared out. We have 1 over x left. X approaches infinity, 1 over x equals 0. So then we have all the 0. We just need to have the non-zero number left. So the next one, we do the same thing, limit x approaches negative infinity. The highest degree for the numerator is x cubed. Then divided x cubed to each term, we have 2 over x divided by x cubed is x squared. Then minus 1 over x cubed. Then denominator is x squared. Then 3 minus 2 over x plus 6 over x squared. The x cubed, x squared cancel out. 3 minus 2 give you 1. So we have x left. So we sub in x approaches negative infinity. This x to the exponent 1 is negative infinity. Then 1 minus this one is 0, this one is 0. All over, this is 1 times 3 minus 2 over x, limit is 0, 6 over x squared, x approaches infinity is 0, so we have negative infinity times 1 over 3. 1/3 times 1 negative infinity comparing to negative infinity is just negative infinity. So the C limit is negative infinity. So this is how we use a symbol infinity to find the limits for expressions. So the next one we are going to base on the properties of limit to find the horizontal asymptotes. So horizontal asymptotes, given that the numerator and the denominator are polynomials in terms of x, and degree is n and m respectively, when n is less than m, the horizontal asymptotes is y equals 0. Why it this way? Because if n less than m, the highest degree take out, then the numerator n is less than denominator m, you will have x at denominator, then you will have the whole function equals 0. So the horizontal limits is just you find the horizontal asymptotes, you just find the x approaches infinity, positive or negative infinity, and what's the function's value. That is your horizontal asymptotes. So this one equals something. This is your horizontal asymptotes. So f positive infinity sub in, negative infinity sub in, but when we sub in, we use limit to find the value for the function. It will never ever touch it, but it will get closer and closer to that value. We call that is asymptotes. So now we are going to redo the question 2a and 2b. So if the function, so we copy this function here. If we have a function 1 over x minus 2, so 2a, we just write that expression as f at x equals 1 over x minus 2. Then the horizontal asymptote for this one is just we find the limit when x approaches positive or negative infinity. We could write them together. So 1 over x minus 2, then we sub in, we have 0. And actually, we could write it separately. So if positive infinity, then we have positive number here. So 1 divided by a positive number give you positive. So it's from above to approach it. And if limit x approaches negative infinity, 1 over x minus 2. So 1 over x give us 0, but if negative number we put here, 1 divided by a negative number give you negative number. So it's a small number, but it's negative. It approaches the zeros from the bottom. What it means is this is our x, this is our y. Horizontal asymptotes is y equals 0. And if it's positive infinity, it approaches from the above. If negative infinity approaches negative infinity, the y value is negative, so it approaches 0 from the below. So this is what it means. So approaches the asymptote from the above or below. Okay. So this is above. This is below. So why we want to find all this information? Because it will help us to graph the function. And after that, we are going to see the second one, 2b. So 2b, if f at x equals, copy that function here, is x squared minus 2x minus 1, 3x squared minus 2x plus 6. So x squared minus 2x minus 1, 3x squared minus 2x plus 6. So limit, when x approaches positive infinity, we have done it. We take the highest degree x squared out, then we have 1 over 3 left. And we are going to see is positive or negative. So 1 over 3, we could do it again. Okay. So x squared, take x squared out, then we have 1 minus 2 over x minus 1 over x squared. X squared, 3 minus 2 over x plus 6 over x squared. Then equals, cancel out, you have 1 over 3 left. If x is positive, then this part is comparing to these two numbers will be really small, so it's always positive. There is no negative sign give you from here. And same thing for limit x approaches negative infinity, f of x equals 1 over 3. Even if you put negative infinity here, comparing to 1 over 3, it is too small, so it's still positive. So it's still from above. So what it means on the graph is xy, then the horizontal asymptotes is 1/3. Y equals 1/3. And when x approaches positive infinity, it's about to approach 1/3. So negative infinity is approaches negative 1/3 from the above. So this is what it means. So this is a horizontal asymptotes. So when the degree, this is 0, this is 1, the degree n, m, this is 0, this is 1. If n is less than 1, then you have y equals 0. Y equals 0 as a horizontal asymptote of both degree equals. Highest degree 2, 2. Then the horizontal asymptote is just the number at front, the coefficient divide. So in future, you don't have to show me the limit. You could just, okay, 1 over 3, this one less than the denominator degree, then it is y equals 0. So you just show me the degree is, numerator degree is lower than the denominator degree, the horizontal asymptote is 0. The degree, highest degree equals, then it's just a coefficient at front. You don't have to show me all the steps for finding limits. Okay, so you can treat this as a conclusion. You could use it right away. So this is for horizontal asymptotes. Then we are going to see the next one. We have done the vertical asymptotes is denominator equals 0. Then horizontal asymptotes is if the degree above is greater, is lower than the denominator is 0. If equals, just the number at front. And the last one is oblique. Oblique means numerator, denominator, the degree is higher. So we just deal with higher than 1. So the numerator highest degree, the denominator highest degree, n is greater than m. But we only deal with n is greater than m by 1. So it's not horizontal, but will be slant. It's a straight line, slanted. So steps for finding oblique asymptotes is do the long division. Then determine the limit at infinity of the remainder. From the step 1, then that will be 0. So what's the quotient? Will be the oblique asymptotes. So here we want to find the quotient. This is we call dividend. This is our divider and divisor, and we want to find the quotient and the remainder. So I will show you several different ways. So the first one, we just use a long division. If you don't have to know all those methods, okay? So I will show you the long division first. For the long division, we just copy the dividend here. So x squared minus 3x plus 1. And here, be careful, you need to write it in standard form. And if the degree must be decreased by 1. If you have one term, for example, x to the exponent 1, you don't have it, you need to write 0x. So it's kind of you have hundreds, tens, ones, they must be aligned very well. So x minus 2. Then first term divided by first term, x squared divided by x is x. We put the x at this tens place. So then we times it. X times x, x squared. Minus 2 times x, minus 2x. Then we subtract. So x squared minus x squared is 0x squared. Negative 3x minus 2x give you negative x. Minus 3 plus 2 minus x, then plus 1. Then we do the division of the first term. Negative x divided by x is negative 1. Then we times it. Negative 1 times x, negative x. Negative 1 times negative 2, positive 2. Then subtract again. Negative x minus negative x is 0. 1 minus 2 give you negative 1. So this one, if we write it as a dividend equals divisor is x minus 2, quotient is x minus 1, then remainder is minus 1. So this is and divide by x minus 2. Okay, so this is then we could write it as a quotient. Then remainder divided by divisor. So this is how. You don't need to write this step. So this is what f at x equals. Then once we have this quotient and remainder, we could find the limit when x approaches positive or negative infinity. If we don't care about from above or below, we just want to find the asymptotes, we could write positive, negative, infinity together. Okay, so then we are going to have, we just find the remainder when x approaches negative or positive infinity. This part determines the above or below and the behavior. So we sub in, we know this is 0, so it will be 0. And if from above you will see it's negative, then 1 divided by positive is from negative direction. And if it's negative infinity, we put here is 1 divided by negative, then negative again is positive 0, is from above. So this is when x, so what it means is the function, we have x minus 1, so if we graph this line, y equals x minus 1, then when x approaches positive infinity is from below, it means it's the function f of x. When x approaches positive infinity, it approaches y equals x minus 1 from below. And the negative infinity is from above, is to approaches y equals x minus 1. So this is what slant oblique asymptote means. So this is x, this is y. So it approaches this one. At middle, it could cross the asymptotes. Only when x approaches positive, negative, infinity, it will approach that asymptote. Middle, the graph could cross. So, and this question is a little bit tricky. It asks you to find all asymptotes. So by doing the division, we find the oblique asymptote. we don't have to do the long division each time, only when the numerator and the numerator degree is higher than the denominator degree by 1. Otherwise, if it's less or equal, we have a constant number. It will be horizontal asymptote. So if we have oblique asymptote, we don't have horizontal asymptote. And another asymptote we have to consider is vertical asymptote. The vertical asymptote is coming from the denominators zeros. So we are going to, the vertical asymptote will be the denominator equals 0, we have x equals 2. So for this function f at x, we have x equals 2 and y equals x minus 1. So we have 2 asymptote. Another one is horizontal asymptote. Vertical asymptote and oblique asymptote. So there are two things. For the vertical asymptote, we could consider from left or right. So if we sub in the numbers on the left, x equals maybe 1.9 to the equation to find its positive or negative, then we know it is approaches from positive infinity or negative infinity here. But it didn't ask you to find the behavior from the positive negative infinity, then we just write vertical asymptote is x equals 2 oblique asymptote is y equals x minus 1. Then this question is done. So these two asymptote and the mark will be given these two correct, and the middle will be the long division correctly. You do the long division correctly, then you show the limit of the remainder is this part, remainder is 0, then it's done. So 1, 2, 3, 4, 5 marks for this question. Then we are going to the next one. Next one is similar, but it's just higher degree. So this is x cubed. And in standard form, and make sure each degree is going by reducing by 1. If no degree for x squared, we put 0 at front. Minus 4x plus 1, so it's kind of like thousands, hundreds, tens, ones. And x squared, 0x minus 1. So first term divided by first term. So these two do the division. 2x cubed divided by x squared, we have 2x. We put 2x along with x. This is our tens place. Then we find this by doing the first divided by first. Then after that, the second step is multiply this quotient times that one. So times with this to put here. So 2x times x squared give us 2x cubed. Then 0x squared minus 1 times 2x minus 2x. Then this is our second step. Then third step is subtract. So align very well. 2x cubed, subtract 0, this one 0, this one subtract, negative 2x plus 1. Then this one, we don't have x squared, so it will be 0x squared divided by x squared is 0, so it's just 2x. Because this is 0x squared. 0 divided by 1 give you 0, so we don't have to write 0x squared here. Then we could write it as f at x equals, we don't have to write the whole thing out, it's just a quotient, 2x plus 0, then plus remainder, negative 2x plus 1 divided by the divisor, x squared minus 1. So this is quotient, remainder, divisor, and from here we could write a remainder limit negative 2x plus 1 over x squared minus 1. So this is factor the highest degree out. X negative 2 plus 1 over x, highest degree x squared, 1 minus 1 over x squared, then x squared cancel out. So you will have 1 over x left. Limit 1 over x is 0 times negative 2 plus 0 divided by 1 minus limit 1 over x squared is 0, so 1 minus 0. So the whole thing is 0. So it works. So when x approaches positive or negative infinity, you have the oblique asymptote is y equals the quotient 2x. So this is our oblique asymptote. Then we are going to see if we have any if we have oblique asymptote, we don't have horizontal asymptote. So we just need to find, do we have vertical asymptote? The vertical asymptote is just denominator equals 0. Then we solve it. We have x, we could factor it, or we could move the minus 1 to other side, x squared equals 1, then square root. We have negative 1 and positive 1. So in this function, for this function, we have y equals 2x as our asymptote, oblique asymptote, and also we have x equals negative 1, x equals positive 1 as a vertical asymptote. So 3 asymptotes for this question. Then we are going to see the last one. For the last one, before we do the long division, we look at the degree. So numerator degree is 1, denominator degree is 2. Numerator degree is less than the denominator degree. Then actually we know it will be horizontal asymptote, and it will be y equals 0. When these two degrees same, it will be the number at front. So if less than, it's just y equals 0. It's done. Then we need to find the vertical asymptote. If we have horizontal asymptote, we don't have oblique asymptote. We just need to find the vertical asymptote. Vertical asymptote is just a denominator equals 0. X squared minus 3x minus 10 equals 0. And also we have to make sure the 0 is not 0 for the numerator. If it's 0 for the numerator, it's a whole, not horizontal, not vertical asymptote. So this is a simple trinomial, xx, no other ways. Two numbers times together is negative 10, add together negative 3, so it's 2 and negative 5. Then solve it, we have x equals negative 2 and x equals 5. So they are our vertical asymptotes. You don't have to graph this one, but I like to graph it to show you where are the asymptotes. So horizontal asymptotes is y equals 0. We have x equals negative 2, x equals 5. So they are the 3 asymptotes for this question. So in this lesson, what we have done is horizontal asymptotes, vertical asymptotes, and oblique asymptotes. Horizontal asymptotes, if the degree is lower, the numerator is lower than the denominator, is y equals 0. If the degree is same, just number at front divide. And for vertical asymptotes, always the denominator equals 0. And after you have the zeros, make sure they are not the zeros for the numerator. Otherwise, it's not vertical asymptote, it's just a whole. And for oblique, it's the degree of the numerator is higher than the denominator's degree. Then we do the long division. So when we do the long division, make sure if one term is missing, we put 0x, the degree there. So degree must be 3, 2, 1, 0 in order. Then first term divided by first term to get the first term of the quotient, then times the quotient with a divisor, then subtract from the dividend. Then the first term divided by first term again to get the second term of the quotient. Then make sure show the limit of the remainder is 0. Then our conclusion is the first part, the quotient is our oblique asymptotes. So that is all for today's lesson, and we'll check your understanding is on Delta Math 4.3. Thanks for watching.